Welcome to Advanced Factoring Strategies, and we're going to delve into the lower two here, number 4 and number 5 on our list of things we should look for. However, always look for these first, which is actually going to happen on the very first problem. So, do you see a GCF? Yeah, both terms have an x. They can give away, factor out. And I have x squared minus 64. And then at this point, I really have the difference of two squares. So this is a perfect square, and this is a perfect square. This is 8 squared. And so we will have x, and then two things multiply to give me 64 is 8 times 8. Signs must be different because it multiplied to give me negative and a 0 in the middle. There we go. The next problem looks almost exactly like it, but it's very, very different. So GCF? No. Okay, let's look through our list. GCF? No. Is it a trinomial? No. Is it the difference of squares? No, actually, it's not. It's the difference of what? It's not a square, but it is the difference of cubes. Could be the sum of cubes, could be the difference of cubes. So let's park here for a while. These are on the previous notes, and there are two formulas that you're going to need to write alongside number 4, and here it is. For the sum of cubes, let's suppose I have two perfect cubes like a cubed and b cubed, whatever they may happen to be. A cubed and b cubed. It could be x cubed plus 27, which would be 3 cubed. I can factor that using this. Now when I write this, it's going to look really confusing, but I'll try to clarify it for you. It's going to be a plus b, and then a squared minus ab plus b squared. Excuse me. Okay, so I'll write the second one in a second, but this is the sum of cubes, which is fairly obvious because we're adding two cubes together. But I want to point out some things that will help you understand this formula and kind of memorize it. It's really not that hard to memorize. So a cubed plus b cubed is a plus b. No big deal there. So a cubed plus b cubed, a plus, just take the cubes and knock them off. And then for this one, you're going to have a squared and b squared at the beginning and the end. In the middle is going to be ab. But this sign is always going to be the opposite of that sign. Okay, hang with me here. This would be the difference of cubes. Makes me clear my throat. A cubed minus b cubed is a minus b. Notice the similarities. Let's just knock your cubes off. And then you're going to have a squared, b squared at the end, and ab there. This is always going to be positive. And let's make that look more like a b and less like a 6. And this is going to be a positive. So basically they're one formula. You just have to notice the different nuances. So this is always going to be the same sign. This is the opposite sign, and that's always positive. So let me write this a slightly different way, the way a former student showed me this. This is the same sign as this one. This sign right here is the opposite. And this sign is always positive. Okay, so notice we have same sign, opposite sign, and then always positive. And what the student was showing me, and I hope it shows up in yellow there. Sorry if it's not. But what the student showed me was S-O-A-P. It spells soap. You know, isn't that the neatest thing you ever did see? I thought so too. Okay, let me change the color of this so y'all can see it a little bit better. Just in case it's not showing up, we're going to make it purple. And apparently it changed one of the variables as well. It changed that B to a purple B. That's going to bug me. That's really going to bug me. So even though it might be a waste of time, I'm going to fix that very quickly. And let's make this a blue B. There we go. So same sign, opposite sign, always positive. So what I want to do is take that idea, run with it on the problem that we paused just a few minutes ago, and let's do it now. So this is the difference of two cubes. Okay, so two cubes, So it helps to know what the cubic numbers are, and I just want to point out something that's fairly obvious, I hope, and that's this. X cubed is x cubed. That's obvious. Maybe not quite as obvious is that 64 is 4 cubed. Now you could say, well, I thought it was 8 squared. It's that too, yeah? This is the same as that. So what I'm going to do is factor this using that same structure I just had. I wrote it in blue, and I'm going to write it again right here. And that would be a cubed minus b cubed equals a minus b, same sign, then a squared, opposite sign, and then always positive. So what I'm about to do is treat all my x's like a's, let me rephrase that, all my a's like x's, and all my b's like 4's, and we're going to just fill this in. So let's do it. Let's switch colors again. My final answer is going to be right here. I'm using this to guide me. So a minus b is x minus 4. So far, so good. Okay? A squared, well, a is x, so we're going to have x squared. And then I'm going to skip to the end. B squared, well, that would be 4 squared, so that's 16. Go ahead and put 4 squared, stretch it out an extra step if you need to. And then AB is going to be, well, x times 4. Well, that's 4x. This is always positive at the end, but this is the opposite. So same sign, opposite sign, and then always positive. There we go, it's factored. Now, notice this. Quadratic trinomials, okay? Quadratic trinomials. I'm going to try to factor that. Let's move forward here. Knowing that this is potentially my final answer, and I don't need this formula anymore. It just guided my answer. But this is my final answer. I'm going to try to factor this x squared plus 4x plus 16. And I'm going to do it down here because I'll go ahead and tell you it's going to get us nowhere. But I want you to realize that not every trinomial factors. It's always worth trying, but that don't always factor. So here goes. X squared plus 4x plus 16 in the worst handwriting possible, and we'll break this up. So x and x, two numbers multiply to give me 16. So 16 could be 1 times 16. My goodness, when I know it doesn't work, my handwriting gets really bad. 1, 16, 2, 8, 4, and 4. I want to be able to add those and get a 4. You will never add those and get a 4. You'll never do it. It won't happen. So this one's not going to factor. So this got us absolutely nowhere. This was useless. This is as far as I can go. Anytime I am factoring using the sum or difference of cubes, the trinomial that appears does not factor. Unless it's some weird special case, but that's not going to happen generally right now. I'm trying to backtrack because I say it never will, but then like if you use some instances it might, but we're not. I'm trying to think of how that would work in my head. Anyway, for now, let's not.